So we're going to take a closer look at the absolute value function. And this is going to be our first example of a series of special type of function that we call piecewise functions. Absolute value functions. Let's remind ourselves what the absolute value of a number is. Maybe let's start with the easiest of all numbers, the absolute value of 0. So the absolute value, there are different ways to think about it. You can think about the absolute value as being the magnitude or the modulus of the number. You can also think about the absolute value as being the distance from that number to 0. So the distance from 0 to 0 is 0, and also the magnitude of 0 is 0. So the absolute value of 0 is 0. The absolute value of 2, so the magnitude of 2, or equivalently, its distance to the origin or to 0 is 2 as well. The absolute value of minus 3, what is that? Well, minus 3 is here. The distance from minus 3 to 0 is 3, or in other words, the magnitude of minus 3 is 3. So as we can see, in these two cases, okay, we've got the absolute value of a number that's actually non-negative. So if you've got a number that's non-negative, its absolute value is just the number itself. Okay. And in this case, or maybe I can include more cases with negative numbers, you end up with the absolute value of x being the... So one way to see this 3 also is to think of it as the opposite of minus 3. And minus 7 is the opposite of minus 7. So it's the opposite of the number we have inside the absolute value bracket if the number is negative. So it's going to be minus x. So sorry, it's going to be the opposite of x if x is negative. So we've got two cases, okay, case 1, case 2, and two rules. So in case 1, this is the rule. In case 2, this is the rule. So when you have multiple rules and multiple cases for a function, this is what we call a piecewise function, because we're going to write it like this. We're going to say the absolute value, and this is actually a way of defining the absolute value. The absolute value is x if x is non-negative, and the opposite of x, and be careful, this is going to be a positive number if x is negative, because if you take the negative of a negative, you get a positive. So in all cases, you get positive numbers. So we have two rules, and that apply depending on the case that we encounter. So let's look at the graph now. Let's look at, so to graph something that's defined piecewise like this, we're going to graph each piece and glue them together. So the first piece is when x is greater or equal to 0. This is case 1. Okay. The rule is y is going to be equal to x. So this is sort of restricting the domain where we're going to graph that function y equals x. So y equals x, of course, looks like this, but we're just going to keep the part of that graph where x is greater or equal to 0. So that's going to give us this. Okay. Then the other part applies when x is negative. In this case, the y value is minus x. Now, minus x looks like this, but we only keep the part where x is negative. So that excludes 0, by the way. So there's an empty dot at 0. And we've got this function with a slope of -1, right? A line with a slope of -1. So to come up with the graph of absolute value of x, we're going to glue, or we're going to add up these graphs, okay? So we're going to have this part with a full dot, this part. Now this part has an empty dot, but then if we glue it, then it's glued where this empty dot gets filled by the full dot of the first curve. So essentially we've got a full dot where they meet, and we don't need to put a big dot like this. It's obvious if it's a continuous curve that this dot is full, because there's no, essentially if there's no empty dot, there's a full dot. So this is not my best V shape. So this is a V shape graph like that. Okay, slope of -1, slope of 1, and that's a graph of the absolute value function. So maybe you can put equal like that. So this is my personal notation, by the way, adding graphs to get another graph. Okay, so if you want to, you can just not put anything and just understand in your head that you're gluing those two pieces together. Well, I like to write that. I mean, I just thought about that. That looks kind of fun to write it this way. So that's our first example. Second example is taken from the Quebec government website. And we're going to look at the income tax rates for 2020, actually. So if you're paying taxes this year, I don't know if that's your case, but maybe your parents are, this is what they're really going to apply. So this is no joke. Those are actually real numbers. So there's something called the taxable income. Okay, so taxable income is not necessarily your salaries, because from your salary you have a lot of things that you can deduct from it. After you've deducted everything, you get what's called the taxable income. Now in Quebec, as of 2020, and this changes every year, by the way, if you earn less than $45,000, $105, okay, your rate, okay, the amount of tax you're going to pay on this will be 15%. So you're going to pay 15% of whatever you earn below or equal to that amount. Now, if you earn more, if your taxable income is more than 45,105, not my best dollar sign, like that, okay, I'm cheating a bit, by the way, because there are more tax brackets afterwards. But let's say I'm going to simplify this a little bit. So let's say you earn more than $45,000. So it's false if you earn above something like $90,000. It changes again. But at least my example is good if you consider someone earning less than $90,000. So if you earn more than $45,000, for that portion you're going to be taxed at a rate of 20%. Okay, so if you earn, okay, so we're gonna call the tax. So I'm gonna let the tax function so we're gonna see how much taxes you pay, BT, okay, and I'll call X X is gonna be my input, the taxable income. Okay, if I look at what I'd like to know, I'd like to find a formula for T of X. Now, if I earn less than 45,000, it's pretty easy. It's going to be 15%, so 0.05, multiplied by my taxable income. So, okay, so maybe we can just write 0.15x like that. If I earn, so this is actually if X is less or equal to 45,105. However, it's different if you earn more than that. So you see here I have two cases, and they're going to have two rules. So if you earn more than $45,000, okay, what's going to happen is that the answer is not going to be this, okay? That's not how it works. So the way it works is that the government will tax you 15% on the first 45,105 amount. Hang on. So let's say let me re-explain this clear in a better way. Let's say you earn $70,000. Okay, so on that first $45,105, the government's going to take 15% of that. For whatever is left, so here, the government's going to take 20%. And after that, in reality, if you earn, let's say 150, there are more tax brackets. So So there are more rates coming up if you earn more. But like I said, below about $90,000, anything below that is that portion between 45 and 90 is going to be taxed at 20%. So the way it's going to work for your function is that the government is going to take 15% of the first 45,105, and then it's going to take 20% of the remaining portion. So down the remaining portion, we have to take our salary or taxable income, X. Okay, so this is what that $70,000 stands for. That would be, let's say, our taxable income, and we need to subtract 45,105. So that gives us this part here. So this is X minus 45,105. And for that portion of the taxable income, we get taxed at a rate of 20%. So that gives us our rule. We can actually simplify, well, not simplify, at least we can calculate the first term, 0.15 of 45,105. That gives us $6,765.75. I'm going to keep the remaining portion like this. So if you're using a software to produce your tax return, it's going to actually calculate this. So the software uses that function somewhere. Okay, so someone has to program that into the system. So maybe collecting everything in one place, we have T of X, it's 0.15x if X, the taxable income is less than this, and if X is greater than this, 45,105, the rule is 6,765.75 plus 0.2 of X minus 45,105, like that. So I'm running out of space here. So if X is greater than this. So we've got, again, two rules, two cases. And we could graph this, actually. Want to see how the graph looks like? Well, once again, we've got to piece together two curves. So we have to look at this thing here. So if X is less than or equal to 45,105, it's 0.15x. So this is just, if we graph y equals 0.15x, it's a line with a slope of 0.15. So maybe something like that. So it starts at 0, right? If you replace x by 0, you get 0, and you get something like this. And it stops at 45,105. The important thing is that it's going up, and the slope is 0.15. After that, if I add the other portion, it's 6,700, like that, 0.75, plus 0.20x minus this. Okay, this is, once again, it's a line. Notice it's in point slope form. Okay, because it's the form, it's of the form y0 plus m times x minus x0. Okay. So the slope is, this is your slope. This is x0. This is y0. So at 45,105, it starts here at this. And notice this thing here, it was obtained by doing, we did it here, right there, 0.15 of 45,105. So by the way, 0.15 of 45,105, that's what you would get if you would replace x by 45,105 into the first function. So in fact, our first function also goes through that point. Okay. Like that. Okay, so they go through the same point, and actually this is an empty dot because we have a strictly greater than, right? The rule is, I didn't write it down, but the rule is this is when x is greater than 45,105, so it starts with an empty dot like that, and the slope is 0.2. Now 0.2 is slightly above 0.15, so it would go up a little bit more. I'll just exaggerate. So if you piece the two lines, the two graphs together, you are going to get something like this. Okay, so it's a piecewise linear function, and the slopes here correspond to your tax rates. Okay, and so in real life, the function actually has more pieces. Okay, like I said, it changes again at 90,000. The tax rate is a bit higher, like so maybe something like 22%. I didn't look it up, but yeah. So this is how the graph looks like for the first two tax brackets. Pretty cool. So it's a real I don't know, life problem for, I don't know, accountants, people going into business, but actually everybody, because this is how you pay your taxes. So we're going to finish with something simpler here. Sketch the graph of the function. So this one, it has three cases and three rules. So the first rule is x squared if x is less or equal to 1. It's 3 if x is between 2 and 1. It's x if x is above 2. I mean, just to understand what this means, like if I asked you what's f of 3/2, okay, f of 3/2, you'd have to find like which case applies. Is 3/2 less or equal to 1? No. Is 3/2 between 1 and 2? Yes. Okay, so the rule that applies is 3. Okay. What's f of 4? Then you look like 4, the first case, second case, third case, it's the third one, right? X is greater than 2. So it's going to be x. So it's going to be 4, right? So this is a rule that applies in this case. Okay, so you see how that goes? So now we've got 3 curves to glue together. Okay, so let's do that. So we've got x squared. Remember, x squared looks like this. This is from our toolkit functions. But we need to only keep the part where x is less or equal to 1. So this is 1. What's this point? Well, remember, we're graphing y equals x squared. So 1 squared is 1 as well. So it goes, but we only keep the part where x is less or equal to 1. So I'm going to have to erase this and just keep this part like that. Plus, after that, x is 3 if it's between 1 and 2. Notice that 1 and 2 are excluded here from the interval. This is 2, actually. So we're going to have empty dots at the end of this portion of the curve. And we graph y is 3 from our toolkit. That's a constant function. So it would look like this. Okay, notice this would be 2, 3. And this would be 1, 3. Okay, and then we've got x, the graph, y equals x, and this happens, well, this rule holds when x is above 2. So above 2, so this from our toolkit, this is y equals x, so at 2, we're at 2, 2 here. But let's be careful, it's when x is greater than 2 strictly, so we're going to have an empty dot there, and we just go up. And then we put everything together. Okay, so we've got our parabola like that. It stops at 1, 1. Now 1, 3 is above it. So this is, you know what? This is, I don't have enough space. Let me graph it here. Like that. Okay, 1, 1. Then 1, 3 is above it. It's an empty dot. Go like that all the way to 2, 3. And then at 2, 2, we've got this line going up. This is what the graph looks like. So we've got what we call here a jump in the function. Okay, we're going to study this a lot in calculus. We've got 2 jumps. And that's pretty much it. So the key point is to take your time when you graph this, especially at the beginning. Don't try to graph everything at once. I would break it down like I just did. Once you get good at it, then you can maybe put everything together in one shot.